In this video, we'll look at a few questions from a worksheet on capacitance. We'll begin with question 1. Now, question 1 of our question says that a capacitor stores 5.0 times 10 to the minus 9 coulombs of charge, electric charge. Calculate A, the number of electrons which must have flowed into the capacitor, and B, the capacitance of the capacitor if the PD across it is 5 volts, and C, the amount of charge which must be removed from the capacitor to reduce its PD to 1 volt. So first of all, what we're given is the capacitance, well, not the capacitance rather, but the amount of charge the capacitor stores. So this is question 1. So we have the charge stored, Q, equals 5.0 times 10 to the minus 19 coulombs, right? Now the question basically asks us, the first part of the question asks us the number of electrons which must have flowed into the capacitor. Now we know that basically when it comes to electricity and charge, essentially electrons are the mobile charge carriers, and it is the ability of electrons to move which basically allow bodies or objects to become charged. So if a capacitor becomes charged, it basically means that electrons would have flowed onto one plate of the capacitor and electrons would have actually been removed from the other plate of the capacitor. And basically the number of electrons which would have flowed or have been removed from the plates will basically determine how much charge the capacitor would have acquired. So we can basically say that the total charge Q is equal to the number of electrons N times the charge on one electron. And of course, we know the charge on an electron is 1.6 times 10 to the minus 19 coulombs, and therefore what this means is that the number of electrons N is equal to the total charge Q divided by the charge on one electron, and this gives us 5.0 times 10 to the minus 19 divided by 1.6, so 19 coulombs divided by 1.6 times 10 to the minus, this should be 9 rather, 10 to the minus 9, so 10 to the minus 9, and this is 1.6 times 10 to the minus 19 coulombs. And that basically should give us 3.125 times 10 to the 10 electrons. So therefore the number of electrons would necessary to have flowed into the capacitor for it to become for it to acquire this amount of charge is 3.125 times 10 to the minus 10 electrons, right? So that's part A of the question. Now, part B of the question wants us to find the capacitance of the capacitor if the PD across is 5 volts. So if the PD V is 5 volts, and of course from part A, the charge stored is 5 times 10 to the minus 19 coulombs, from our definition of capacitance, the capacitance C is equal to the charge stored divided by the PD across the plates of the capacitor, and therefore this gives us 5.0 times 10 to the minus 9 coulombs divided by 5 volts. So this gives us 1.0 times 10 to the minus 9 farads, or we can say that is equivalent to 1 nanofarad, right? So therefore the capacitance of this capacitor is 1 times 10 to the minus 9 farad, or 1 nanofarad. Good? So that is part B of question 1. We'll now look at part C. Now part C says to calculate the amount of charge which must be removed from the capacitor to reduce its PD to 1 volt, right? So we can do this quite a few ways. Since the PD has now been reduced to 1 volt, we can use the PD together with its capacitance to find the actual charge stored, and when you find that value of the charge stored, we can basically subtract it from the previous charge stored, right? So using a PD of 1 volts, so V equals 1 volts, and of course you know the capacitance C, which of course remains constant. The capacitance C is 1 times 10 to the minus 9 farads. Then of course the charge stored Q would be given by Q is equal to CV, and therefore 1 times 10 to the minus 9 farad times 1 volt, then this will give us 1.0 times 10 to the minus 9 coulombs. So therefore that is the quantity of charge stored when the PD is 1 volt. But of course initially the PD was 5 volts and its total quantity of 5.0 times 10 to the minus 9 coulombs of charge. So therefore the charge removed is equal to 5.0 times 10 to the minus 19 coulombs minus 1.0 times 10 to the minus 19 coulombs, which gives us 4.0 times 10 to the minus 9 coulombs. 9, not 19. So once again, I have to correct that. So the quantity of charge removed is 4.0 times 10 to the minus 9 coulombs. All right? So that is question 1 from our worksheet.